What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 6.2, which is bisector of triangles. So what we're going to be able to do is look to find the circumcenter of a triangle and use it, and then also find the incenter of a triangle and use it. First thing we're going to do is copy down the following 3 points. A concurrent, which is lines, right, or segments. It's when 3 or more intersect in the same point. We'll see those today. We have point of concurrency. That is the point of intersection for the concurrent lines, rays, or segment. And then the circumcenter is the point in a triangle where those 3 perpendicular bisectors are going to intersect. So once you have those copied down in your notes, let's go on and look at our first theorem. Our first theorem today we're going to talk about is the Circumcenter Theorem, and that just states the circumcenter of a triangle is equidistant from the vertices of the triangle. So if we can see that letter P is showing the circumcenter, because PD, PE, and PF are perpendicular bisectors, then PA is equal to PB, and that's equal to PC. So that means point P represents that circumcenter because those are all equal distances from that point to the vertices of the triangle A, B, and C. So what we're going to do here, it says 3 snack carts sell hot pretzels from points A, B, and E. What is the location of the pretzel distributor if it is equidistant from the 3 carts? Sketch the triangle and show the location. Really, we just want to make sure we sketch this triangle in a way that the segments are going to show the equal distances. It does not have to be perfect, but try to at least show those at first. The first thing we're going to do is go ahead and connect all 3 of these points and make it a triangle. You probably can get a straighter line on your physical paper. The next thing we want to do is we want to be able to do those perpendicular bisectors. So one thing we might want to think of is, can we make A and E have the same distance on either side? So maybe right about here. So that means this segment from A to midpoint would be equal to this segment. I know it doesn't look perfect, but again, I'm making it look better with how I'm drawing. We want to do that same thing with the other line segments on the outside of the triangle. So let's do A to B. Let's maybe say that that halfway point is about here. And we can mark that with, this is 2 tick marks, and this is 2 tick marks. I'm also going to show that this is a right angle for that perpendicular bisector, and I forgot to do that here, so I'm going to also show that there. And then our last one, B and E, also need to have that perpendicular bisector, so we're going to assume it's probably about here, and I'm going to show that with 1 tick mark on each side, right angle here, and you can see that all 3 of them are coming in contact right here in the middle. So that would be where the circumcenter would need to be. Okay. All right, next one, it says the circumcenter P is equidistant from the 3 vertices so that P is the center of the circle and passes through all 3 vertices. So as shown below, the location of P depends on the type of triangle. The circle with center P is said to be circumscribed about the triangle. Okay, so we have 3 separate types of triangles here, so we're going to talk about what each one looks like. The first one is an acute triangle, and we know that because P is on the inside of triangle. This next one is a right triangle because P is on the triangle. And then the last one, you can probably guess it, this one is an obtuse because P is outside the triangle. So these are the 3 ways you can tell what type of triangles those are based on where point P is. The next thing we're going to do, it says find the coordinates of the circumcenter of the triangle with the following vertices. So what we're going to do first is we're going to go ahead and plot these points, and then we're going to be able to use those points to help us find the circumcenter. Let's go ahead and do that. All right, what I've done so far is just I plotted those original vertices and labeled them S, R, and T. The one thing I want you to make sure you understand too is that this looks like a right triangle. So because this is a right triangle, if you go back to what we just talked about, P is probably going to be on the triangle somewhere, okay? How we can be able to do that is we're going to find the two perpendicular bisectors that are easiest. So I know if I look at from R to S, this is 1, 2, 3, 4. And since it's a 4 unit distance from R to S, halfway through that is going to be here. Okay, so that's one perpendicular bisector. My other one, if I look from R to T, this is 1, 2, 3, 4, 5, 6. That means halfway across would be 3. So I'm just going to count 1, 2, 3 tick marks, and this will be my perpendicular bisector for this one. So now, as I'm seeing where my perpendicular bisector is connecting, this is going to be where my new circumcenter would be. So that coordinate, it looks like, is at -4, 2. Okay, so one more time, all I did is I choose to find two perpendicular bisectors that are easiest. Okay, I could have chosen S to T, but that one I probably would have needed to use the distance formula and then find the midpoint of that, just because you can see all of the points are going at a diagonal, whereas R to S and R to T, those are right on the lines for the X and the Y axes. Here's one that I want you to try. See if you can try this one on your own. Again, use that two perpendicular bisectors that are easiest to try to find where your circumcenter would be. All right, the first thing you're going to do is find your points. Let's go ahead and label all of my points, W, X, and Y. And again, this one is looking like a right triangle. So because it's a right triangle, that means my perpendicular bisector or my circumcenter is probably going to be on the triangle itself. Then I find the two easiest perpendicular bisectors. I'm going to start with WX since it's only 2 units across halfway through. And then from X to Y, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm just going to use halfway across, which would be 5. So this is 5 units, this is 5 units. So right here is my circumcenter, which is at 0, -1. Okay. Next up, we have the incenter, which is the point where 3 angle bisectors of a triangle intersect. Okay. That's just going to look like this diagram right here. We have AP, BP, and CP are angle bisectors of A, B, and C. Then that means PD, PE, and PF can all be equal. So that's just 3 different sets, or 3, we have from the bisectors they're equal, and from the vertices they are equal. Okay, so what we're going to do, it says in the figure shown, ND is equal to 5x minus 1, and NE is equal to 2x plus 11. Find NF, and then can NG be equal to 18? Explain your reasoning. What we're going to do first is look at ND and NE. Okay, ND is here, and NE is here, and that is showing that they are equal. So we can go ahead and find what x is equal to by setting these two expressions equal to one another and solving for x. I'm going to move my x's to the left side and my constants to the right side. So I have 3x is equal to 12, x must be equal to 4. Since x is equal to 4, to find NF, I can just plug in 4 to either one of those expressions. I'll use the 5x minus 1. 5 times 4 is 20, and 20 minus 1 is 19. So NF equals 19. Okay, so that was part A. Part B says, can NG be equal to 18? NG does not look like it is a part of the perpendicular bisectors. In fact, it looks like it's a little bit longer. So NG would have to be greater than NF or ND or NE. And since NG, they're trying to say it's 18, but we know NF is equal to 19, we're going to have to say no. Okay? Our last one, another expression example. Go ahead and pause the video here, see if you can try this one on your own. And when you're ready to try it or check your answers, go ahead and click play. All right, we know that QM is 3x plus 8, QN is 7x plus 2. Find QP. Well, QM and QN are equal to one another because those are perpendicular bisectors at the circumcenter or the incenter. So I'm going to set these two expressions equal to one another. 7x plus 2 is equal to 3x plus 8. I'm going to move my x's to the left side, numbers to the right. So I'm going to get 4x is equal to 6. Looks like I'm going to end up with a decimal here. That's okay. I'm going to get x's 6 divided by 4. You can say this is 3/2, or you can write it as a decimal. We're going to use the decimal. So if x is equal to 1.5, let's plug it into this 3x plus 8. So 3 times 1.5 plus 8, that'll be 4.5 plus 8, so 12.5 is QP.